Well, there we have wave action using a metal spring. This is a good illustration of sound for kids to show the idea of transferring energy from one place to another through vibration. I'm using a coil spring. It's available from science supply catalogs. And if you get this thing going really well, you can demonstrate the idea of energy related to wavelength. Let's try with a real gentle wave right here. Like that, very low frequency. If you could hear the sound, that would be just a very low sound to it. But now we'll try it with a little more energy. We'll begin to get that waveform that you can see right now, and that's not too bad. But let's take a lot more energy. And the wavelengths are much smaller, and if we had sound, well, that would be a much higher pitch. But it shows that waves do carry energy, and it takes a lot of energy to make this. Well, that's a good example for classroom use of trying to teach about sound and waves and so forth. But you don't have to have a spring like that, although that's a great one to use. You can also use a slinky. The thing about slinkies is that they tend to sag a lot. So with a slinky, what you'd want to do is lay it, say, on a flat surface like the floor and have the kids move the wave side to side and so forth and transfer energy that way. And the person receiving it can feel the motion when the wave gets there, so that's a good way of showing how energy, mechanical energy, is transmitted by waves. Well, there's a lot of different things that you can do with kids and sound, and a lot of strange things, a lot of fun things to do. If you happen to watch that old film on TV some time ago, Hawaii, there was a native Hawaiian there working a kind of a signal device, a horn made out of a conch shell. And you can make these. They're a little bit tricky to do only because these things are a lot tougher than you'd imagine. But what you do is you cut the end off right here so that you have a hole down this side here. Then you grab it, put your hand into here like this, hold it nicely, it's easy to hold. And like blowing in a trumpet, you blow through the hole. It takes a little practice, so sometimes the sounds are kind of rude, but it makes a very nice sound when you get it just right. And you get the natural frequency of this. So let's try to make a good sound with this. Well, people a long way can hear this, so it'd be a great way for signaling. And different size shells will produce different pitches because of the amount of spirals and so forth and the overall size. This whole thing causes the air to vibrate as it's going through it. So that's kind of a cool one right there. Now, on another part of the world, you might see a very long horn called an Alpenhorn, which it's kind of hard to get one of those around here because they're so big. They're like 5 meters long. But I can make one out of a PVC pipe. This is a 1/2-inch pipe, comes from a hardware store. And all it is, just a straight piece of pipe. Using the same technique of blowing through it, you can produce a sound, which is kind of nice. And you can actually make the sound go up or down by how much energy you put into it. So I'm just going to blow through this thing right now. And let's see if I can make the sound like you would hear in the Alps, the Swiss Alps. Well, that didn't work too well. That does take a lot of wind to make that happen. Well, there are other things you can do with this pipe, and another thing you can do with it is to demonstrate about frequencies, and every material has a natural frequency. And this one has a natural frequency. If you try to move it, you can see how that frequency goes. Now I'm just going to move it gently right here. And you watch right here, when I go up and down like this, not much is happening here, but when I get the frequency right, look at that. I've got a nice natural frequency here. As I move, the whole rod begins to move together. Now if you could see our metal pipes or our tuning forks and so forth, this kind of motion is the natural frequency. And it depends upon the length and so forth. Now, if I try to go more, faster, you can see I've lost the natural frequency. And eventually I can get up to another one if I go fast enough and get it to do smaller waves. Well, when you have it in the middle right here, you're basically at the harmonic part right here. This is called the fundamental on a musical instrument. It's fundamental. And if you get more than one wave on here, then you get your first harmonics and all those musical terms that you can talk about. Well, that's kind of a nice thing to work with, very simple, but if you have kids try this, and they can do it quite easily, make sure you have a clear space in the classroom for that to happen. Otherwise, you'll have something that's comparable to the Three Stooges going on. And you know the kids will love to be able to do that part too. Well, let's see what else I've got here. Here's something that you may or may not want to share with your kids, but it's kind of fun. I got 2 soft drink cans. They're empty, and I'm going to hold them together to each other and cause them to vibrate by blowing between them. So I'll get them real close together and try not to touch them hard, kind of have them a little bit loose and so forth, but touching. And then you blow right about the middle point of the cans. So you got these very lightweight aluminum cans, and let's see if I can get this to work here. Takes a little practice. You may have to do it a dozen or so times before you get that sound, but when you get hold of it just right. But here we go. Oh, that's really loud. So hopefully you don't have every kid in the classroom try that at one time, because that really will hurt your ears. But that metallic sound that you heard there is the cans vibrating onto each other. The air blows through, they bend inward, they bend out, they come back and so forth, and they vibrate, and it makes that really loud, irritating sound. You may have seen in the stores a tube like this, and they might call it a whirl-a-tune, or got different names to it, but it's a corrugated tube, and this is a tube, and it's got the bumps on the inside here, and it's kind of nice because if you take it and twirl it, you can make an interesting sound. Now what's happening is that by twirling, this end here is traveling through the air, big circle. This end here is not going in a very big circle, it's a small circle. And as a result, the tip of this is going faster, a good deal faster than this end. Well, this has to do with aeronautics. What happens is that as it's going through the air, you produce a partial vacuum on this end here, so air will come from this end, where the pressure is a little higher now, and it'll go right through the tube and spill out on this end here. Well, because of the corrugations, it causes vibration, and the vibration produces the sound. Now, a fun trick, though, what the kids will do is to have another tube for them, something like this one here, and you see it's about the same length and so forth, almost the same color, and let's hear the sound of this one. Well, no sound at all. And the question becomes, why? Well, if the kids really look at this thing over, well, they're the corrugations and all that, but they look down inside, and it's a smooth tube on the inside. There's no corrugations on the inside. This is more like a vacuum cleaner hose, because you don't want corrugations in a vacuum cleaner hose, otherwise everything gets caught part way to the vacuum. So the difference between these 2 tubes, besides some obvious size difference, is really this one has corrugations on the inside as well as the outside. This one has it just on the outside, but not on the inside. So we don't get the air as it's going through rapidly. It's not vibrating, and we don't get the sound. So that's kind of a fun thing to do. And by the way, if you see these in the store, toy stores, they're only a couple of dollars. They're great to have. And so it's easy to get several of them. Now, when I was a kid, we used to do something that was a lot of fun, and it's a great lesson in sound. And that's the old soup can telephone. Now, a soup can telephone is quite easy to make. You get a couple of metal soup cans, and you take a nail and a hammer, and you punch a hole in the bottom of each can, like this. You feed a string through there, tie a knot, and then what happens is you're on one can and your friend is on another. And I'm pulling the string out. Here we go. And I get the string out here like this, and you hold the string taut, and you talk through the cans. Well, the string actually conducts the sound of your talking as it goes from one can to another, and you can, at the other end, hearing the person talking, you can have that private conversation. Well, that's really cool. But here's something else you can do, and this is great. What you do is you get the thing stretched out, and have a long string. This is a rather long string here, and you can talk and you can hear it. But if you take, say, a pencil or one of those mallets that you make, and one person on the other end is standing there listening to the sound, and on your end, you tap it, they will hear 2 sounds. That's the cool part about this. 2 sounds. Why is there 2 sounds? Well, we'll explain that right here. In one of our earlier demonstrations, we talked about how sound travels through solid materials faster than it travels through gas. So, when you tap on here with a can, the sound will travel quickly through the string, and you'll hear a tap inside the can. But then the other tap that you hear is the sound traveling through the air, and it lags behind a little bit. And that demonstrates that demonstrates the speed of sound through air and through a solid. So you get that double tap. That's kind of fun to do. Okay, let's see what else I've got here. Oh, I got a couple more things I'd like to share with you. This is something you have to buy in the science supply catalogs. Metal rods that you can purchase, and they come with a bag of rosin. And because rosin's very messy, I keep it in the jar right here, but it's the same kind of stuff that a violinist would use on their bow. And what rosin does, it has a kind of a grab-release type effect. You get it on your fingertips and you drag it across the rod. It will grab momentarily, it'll let go, grab, let go, and it produces a vibration. So first off, I got to get my fingers nice and rosined up by touching the bag here. So I got my fingers rosined up. And then I'm holding the rod in the center. And what I'll do is just tap it to get a vibration started in the rod. Now you're holding it in the center. It's like when I did with that PVC pipe. The middle part hardly moved at all, whereas the ends really moved. Well, I'm at the fundamental right here, and that middle part and the ends will move. We won't see it much because it's a solid metal rod, but it is in fact vibrating. So here, let's try to get this going here. Oh, and that keeps going and going for a long time. It's like playing a violin. You actually are increasing the sound, the amplitude, increasing the amplitude of the sound here by doing that. Grab it there, and it stops. It's really kind of fun to do, and it's very strong and can be kind of irritating. Well, I'm going to leave you with one more thing right here. And this is an old instrument that you can make. It's fun to do. And if you want to have the kids produce a little of their own band, they can do a jug band. The jug band requires, well, these old ceramic jugs, but you can use ordinary glass bottles and so forth for that. And, but you do need to have one special instrument, which is called, well, it's given a couple of names. It's called a wash tub bass. That's one name. Or it's also called a gut bucket, and I believe that has to do with the fact that sometimes strings can be made out of gut, and that's where you get that gut bucket. Now, how to do this is quite simple. You just simply punch a hole through the center of it. Actually, you punch from this side, and you feed a string through here, and you actually have a guitar string on here, or a piano string, I'm not sure which it is. Nice long string, but you can use a wire, an actual piece of string. If you have gut, that would be fine. And you tie it to a stick, and I found this stick after a storm that blew down a branch, so I cleaned it off, and I've got it tight right there. Then you put your foot on this thing, and what you do is strum it. So the point behind this is that the bucket will resonate. So you get the vibration of the string, but the bucket will magnify the sound, resonate with the string. And by changing the tension, by moving the stick out, in and out, you can go higher notes and lower notes. And you can still find these buckets for a relatively low price at a hardware store. And you've got a nice little music instrument, and you can see the vibration of the string. Watch this. See how that's vibrating? You can see the vibration. It's producing the sound, but it's also causing the bucket to vibrate as well. Well, get out your jugs and your gut buckets and so forth, and get the kids going and have a jug band and play some good music. So long.